Now, I'm aware that this is called a biometry workshop, but I am always particular, and more particular as time goes on, to insist that biometry is only a part, a very important part, but nonetheless only a part of the process of getting better bees in this country. And we have to consider the other aspects of this problem along with biometry. In the first place, we have to realize that beekeeping is never a private matter. Your bees fly out and perhaps sting people. Your drones fly out and your queens fly out to be mated. Recent calculations and experiments, observations in Germany have shown that both queens and drones can fly about 5 miles. So if you wish to have a safe area for queen rearing, you need an area with a radius of 10 miles. You can easily see why. And that is one reason why beekeeping should not be done by single people, but by people working in groups. There's a great deal of work involved in queen rearing, and from the nature of the bees themselves, there is that very important reason for working in groups. There are other practical reasons. In order to avoid inbreeding, the Germans and Austrians have long since discovered that a good base is required, a large number of stocks. And the regulations for German bee breeding are that a single breeder must own at least 20 breeding stocks. And a group of people working together used to have to own 40, and it's now 50 stocks. There is another consideration to support that. Since the discovery of the sex alleles and the sex behavior and the mechanism of reproduction in the bee, an American researcher has calculated that a base of 80 colonies is necessary to maintain the full number of sex alleles present in a given population. Dr. Rutner says about 100 stocks is better. Now, don't immediately take alarm and say, I can't keep 100 stocks, so I can't raise queens. I have just said that queen breeding and queen rearing and selection is a matter for group working. And between you, you should own easily 100 stocks. And that will have further advantages. You need a number of queens to select from. I know a commercial queen breeder who sells queens, and he only works with one rearing queen per year, and after the year is over, he gets a fresh one, probably one of her daughters. He hasn't yet brought himself to ruin, but I think it's a certain path to ruining whatever strain he has. You need a number of queens to breed from. You need a larger number of queens to select from. And if you have a group, it means you can take, for example, 6 sister queens from one selected queen and rear them and keep them under observation in different apiaries under different conditions. And then if the work is carefully done, you can make your selection as to which queen is suited for which environment. One person with 2 or 3 stocks could be testing queens from 2 or 3 different strains. You have to cooperate, however, on the breeding part, and that is another matter. From the point of view of the breeder, cooperation is essential for another reason. There is a great deal of work and a variety of skills are required. Not every person has all the skills, and a group of people can work much more efficiently together. I could not possibly, I think, rear queens by myself. John Dewes, with my assistance, is able to rear far more queens than he would alone. He has all the skills, but there is a limitation on time and energy, and between us we do much better than either would do alone. So that is another point of for working together. Now, the next point is the difficult one. You need good bees. You have to start from what's worth breeding from. And since BIBBA was founded, there's been a continual yap, yap, yap of its members and its critics. Where are these bees? Give us these bees and we'll keep them. And the answer is you've got to look for them. They may be in your own apiary or they may be in your neighbour's. You have to look for the bees in your district. We believe that breeding should only be done from pure racers. The reason for that is obvious. Any ignoramus can buy a packet of F1 hybrid seeds and it tells him on it that he cannot expect to raise the same kind of product from them as he can get by buying new seeds. They are hybrids, a combination of strains to produce a certain effect, and it cannot be repeated from the progeny. It has to be started all over again. That is nothing new. It has been the practice of farmers breeding sheep and horses and pigs and cattle. They make crosses for particular purposes. Better milk yields, better beef yields, different kinds of wool, and so forth. And they keep on making new crosses from the original separate strains if they want to keep the same quality of product. And beekeepers should learn from that. And because of the different mating conditions, in the end, it comes down to breeding from a pure race. I could draw your attention to the edition, the American publication by Dadant, The Hive and the Honeybee. In that book, there is a chapter on the races of bees by Dr. Rutner. He surveys briefly the known races and qualities of the honeybees, and at the end he says that hybridisation is probably the way for the future. He wrote that many years ago. Brother Adam is still saying the same thing. Dr. Rutner has come to the conclusion that under the conditions in which bees have to be kept, they're free flying and free mating under normal conditions, only pure races are safe and useful. That is his considered opinion after many years of work. You want the good bees and you've got to look for them. First, you need to know what is a good bee. What do you want from your bees? Well, the first thing is obvious. Bees and only bees produce honey. So you want good honey producers. The production of honey depends partly on the weather and partly on the flora available, and very importantly, on the quality of the bee. You need a queen which has a good egg-laying rate to maintain the size of the, build up and maintain the size of the colony. And you have to have bees which of course are her progeny, which are good nurses. They are only half her children, the other half comes from the various drones. And you require a queen mated which will be vigorous and gather the nectar for the honey. You can only get that, of course, by observation and picking bees that produce good honey yields under regular circumstances. What else do you want? If you cast your mind back to the winter of 1985 and 86, you will rapidly realize there is another quality required in bees. I remember in the latter part of 1985, an unfortunate Lincolnshire beekeeper appeared on television proudly boasting about his Italian bees, how good, gentle they were, what good honey producers they were, and what a great harvest he was expecting when he took them to the moors in Derbyshire. In the spring of 1986, that unfortunate man had not one living colony. That's just one example. I'm used when I'm talking to give examples, and then somebody chips in, no, that's only one case. So I'll give you another. I have a neighbor who kept Caucasian bees, 35 colonies of Caucasian bees. When I heard that, I said, Caucasians, whatever has made you do that? They're gentle, easy, good for beginners. It started the year before. As I got out of his car, I was stung. A car behind stopped and the boy got out and he was stung. As I took the sting out of his face, he was stung again. And then he got into the car. His mother had brought him to get him interested in bees, and he'd learnt something. I went to the same apiary in the spring of 1986. 35 hives, 3 colonies just alive. Do the arithmetic for me. The remainder of the colonies were dead with dysentery. Why? Apparently the Caucasian bees, or those Caucasian bees, had been unable to ripen the heather honey that they had collected. The hives, not a single hive appeared to have died of starvation. There was plenty of fermenting heather honey in the hive. That's a story I've heard before. A friend of mine, not with Caucasians this time, but with midnight bees. Older members will remember what a vogue the midnight bees had a few years ago. The Deydon's midnights. Thousands of queens were imported into France in one year. None were imported the year after. A friend of mine had a number of Deydon queens. He took them to the high moors, and he said he thought he collected pounds of honey when a neighbor with native or local bees collected hundredweights. He extracted his heather honey and bottled it, and next time he looked, it was all fermented. Those bees were unable to handle the heather honey, and his bees died in the winter. So we want bees that are good producers of honey and can survive the winter. During the summer, it's a good thing to have thrifty bees because there is such a thing as the June gap. You may recall that during the last summer we had a period of splendid weather, and it was a time when there was hardly any nectar coming in, at any rate in my district. And bees have to survive the June gap. I can remember having 2 colonies side by side, a mother and a daughter colony. The mother never required more than 10 combs for the brood nest. She produced me honey in that particular year. Her daughter was cross-mated and required 20 combs, 20 frames, which she kept full of brood. And they were starving most of the time. from time to time, I robbed the mother colony of a comb of honey and put it in the daughters. And she produced, that colony was full of bees all the summer and produced no harvest, whereas the mother that was pure mated was able to support the daughter. So you want thrifty bees, and this is a characteristic of the British bee, and it's suited to this climate. Do you like swarms? I think swarming is the most exciting and thrilling experience in the beekeeping year, but not everyone agrees with me. And even I, much as I like swarms and taking swarms, have to admit that it reduces the honey yield and it can be a nuisance. So we want a low swarming rate. That's 4 points I've given you. And then I come to what is a very important point in a crowded environment. If you were keeping bees on the prairies in America, in the United States, if they have prairies there, or in the wide open spaces of Australia, it would hardly matter what kind of temper your bees had. You could wrap up if they were aggressive, but you'd have no neighbors within a great distance to complain. But you do not live under those conditions. You have neighbors. And under new regulations, I don't know whether they're in force or whether we're merely threatened by them, councils will have the power to declare various creatures to be vermin and should be destroyed. And among the vermin are the honeybees. So we require gentle bees. And that's very important. Fortunately, of the races of bees which are native to Europe, 4 different races: Caucasian, Carniolan in the Danube Valley, Italian in the Italian Peninsula, and what snooty people call the Apis mellifera mellifera, the dark bee of northwest Europe. All these 4 races are gentle when they're pure. That's a valuable quality of the native bees of Europe. But the curious thing is that when the gentle races are mated, cross-mated, such as the Carniolan, which is the gentlest, and the mellifera, which is the next to the gentlest, they produce aggressive bees. And sometimes, as with the Caucasian bee, the cross produces one that's extremely susceptible to nosema and other drawbacks. So we want gentle bees, and that means getting pure-bred bees. Now, where are they to be found? The black bee is the native bee of this country. It came here after the last ice age, and that may be 10,000 or more years ago, following the retreat of the ice and the development of flora on which the bee could live. And after the land bridge between this part and the rest of Europe was broken, our bee has lived in isolation until about 1860, when foreign imports began. Over those 10,000 years, it has been able to adapt itself to the vagaries of the climate. And one interesting and valuable characteristic is that it can fly at lower temperatures than the foreign bees. I have never carried out, and I do not know anybody personally who has carried out any tests on this, but it's alleged in Europe that the queens fly, I think, at 20 degrees centigrade, and the drones at 19 degrees centigrade. The late Beowulf Cooper had some experiments carried out in Nottingham University, of which I know no details, but he alleged that the black bee could fly at a much lower temperature, somewhere about 10 degrees centigrade. And this means that they can mate earlier in the year, and it is my experience that they do rear drones and queens much earlier than the foreign bees, and they can mate before there's any competition. This fact explains why there are still pockets of native bees in areas where there have been great imports and many mongrels. The dominant bee has nature on its side. As I've just indicated, the winters that we have sometimes kill off the foreign imports, and the springs may make mating difficult, and so the scales are weighted in favor of the native bee. There are other reasons too to make it predominant, but of course it's widely hybridized because of the heavy importation. But we still find them. Where? Many years ago there was a claim that they were found in the New Forest. I met someone who kept them, and she discarded them because she said hybrids were more productive, and that was her interest. She dressed herself up very closely and didn't care if the hybrids were aggressive. But she said that there were native bees to be found in the New Forest. We circulated a letter among our members asking if they were content with their bees. If so, would they come into a breeding scheme? Were they discontented? Would they like to have them improved? Most of our members laughed at us because they relied on imported bees, but a few responded. And we did quite a wide biometric survey, and I was surprised to find how good many of them were. And the place to look for pure bees is where there has been some old beekeeper who has practiced let alone beekeeping, never imported, never interfered with the mating habits of the bee, let them rear their queens early, and by that means they've been kept pure, and they can be found. Now, not all ruins contain pure bees. At Mount Grace Priory in North Yorkshire, there is a colony of bees in the ruins which is well recorded for having been there for over a century. Legend has it was brought back from the east by the Templars who owned the priory, but I think that's nonsense. But anyway, there is a colony that has been there for over a century, well recorded, and unfortunately it's fallen victim to local imports, and it is a mongrelized colony. So you can't assume that every stock in a ruin is a good stock. The merciful thing, of course, is if it's badly mongrelized, it will probably die out one winter and cease to be a nuisance. You look round like that and you can get surprising reports. Our letter was repeated and printed to be sent to our members, and the Yorkshire Secretary recently hit upon it and decided it was a good thing and sent it to all members in Yorkshire, which has caused us some more work. And some very good news. 2 groups of beekeepers, not just single people, but 2 groups of people, of beekeepers from the Whitby and the Scarborough areas have replied. They have bees which meet 4 of these criteria. They're good honey producers every year, not just in a good season. They're particularly good honey producers on the heather. They expect 2 supers per year. They're good-tempered. They're thrifty. They don't need feeding in the summer. They're gentle, but they're swarmy. This is probably the result of years and years of beekeeping when bees were encouraged to swarm. But now they're kept in modern hives, and all the 2 groups agree that nothing they have done has been able to control the swarming. What can we do? And the answer is give you good advice, be thankful for what you've got, and put up with the swarms for the time being. If you go on giving them plenty of room, a non-swarming type might emerge, but for the time being, be grateful that you have bees that are satisfactory on 4 of our 5 points. Well, that's where you have to look. And then you need, as I've said, numbers and work together. And from that we'll at last come to the biometry. Its new name, by the way, is morphometry. Biometry is, like most scientific words, is Greek. Bios, life, meter, a measure. But bios, there are 2 words for life in Greek, and bios might be a bit misleading, so it's now called morphometry, which is another Greek word meaning the form or the shape. And it means measuring the shape of the bee, and shape includes size as well as quality. Now, it isn't anything new. I don't know when people really began measuring and weighing animals, but I remember when I was in the Antarctic collecting fleas from birds, I became fairly well acquainted with them. And I noticed the difference and the similarities between members of the same species. And I mentioned this to a scientist working with the Falklands Islands Survey. He was a DSC, but I regret I've forgotten his name. And he said, oh, this is a well-known thing. And I learned that it's so well known, it's been summed up as the Bergman and Allen rules. If a species is extended over a considerable environment, as it gets into harsher conditions, moving away from the equator to the poles, or moving away from sea level up a high mountain, it adapts to the harsher conditions. Its body tends to be larger and more spherical to retain the heat, and its appendages, legs, arms, ears, whatever it has, tend to grow smaller. And this, as I say, was so well known among mammals that it was summed up under these 2 rules. Biometry was well known years ago in other branches of biology and zoology. But as applied to the honeybee, it began about 1920 in Russia. They had a practical aim of trying to increase honey yields and pollination. And they did it by studying their bees, concentrating on tongue length and body size. And they did it so thoroughly that they were able to point out that the tongues of bees decreased in length from the Caucasus the further north they went. They were even able to plot lines on a map like the lines of pressure or lines of heat, the isotherms and isobars, and they called these isoglossa, as to mark the shortening of the tongues. And also the body size grew larger as they went to the colder regions. I don't know whether they measured the length of legs, but they would have found something similar. They turned aside to breeding bees with longer tongues, and they succeeded, but they found it was a waste of time because work, and this is a cautionary point to notice, working for one quality only is not practical, because although that quality can be enhanced, other qualities are lost. And the bees that were specially bred with longer tongues were less valuable than the ones that were left to their natural development. And that experiment of breeding bees with longer tongues has been repeated to deal or attempt to deal with particular crops. And longer tongued bees have been developed, and yet they've been no good. So that was the Russian contribution. They began the study of morphometry. It was later on taken up by the Germans, and particularly by a great genius, Dr. Goetze, who was working from about 1930 till his death in the 60s. And he must have been a man of enormous patience and energy. For one experiment alone, he recorded having examined 400,000 bees. Of course, he was a professor, I think, at Bonn, and head of a beekeeping institute, and he had, no doubt, a great staff of people working with him. But nonetheless, he was possessed of enormous energy and patience, and he measured bees in every possible aspect, or almost every possible aspect. And he reduced the important measurements to 2, because he found that many others depended on the few that he measured. And the measurements that are important to us are measurements in the wings. I must diverge for a moment and turn away from the honeybee. All insects are classified by their wings, and they're called after the type of wing they have. For instance, if you pick up a butterfly or a moth, you find you get a kind of dust on your fingers. And those are known as Lepidoptera because their wings are covered with little scales. If you look at a beetle, instead of having 4 wings, it has 2 wings which are hidden in wing cases, wings modified into cases, and they're the Coleoptera. And so it goes on through all the ranges of insects. And it's natural that the bee and its relatives, wasps, ants, ichneumon flies, sawflies, various others, should be known by their wings. They're known as the Hymenoptera. And it's natural that the bee's characteristics should be most clearly seen in the wings. You can look at it another way. The bee lives on nectar and pollen. It requires water and propolis. To get these, it has to fly, so the wings are important to it. It's the only insect that stores pollen because it requires so much, and so it's hairy, and the hairs collect the pollen. So it's from different points of view the wings are important. And Dr. Goetze hit upon, after millions of measurements, he hit upon the crucial ones in the wing. And what we measure, and is most important for distinguishing the races of bee, is what is known as the cubital index. People make fun of this. I read a letter which illustrates the very high scientific attainment among British beekeepers. It was by a bee breeder who is a member of a government committee, and it said, "I do not know anything about biometry, but I agree with so-and-so that it's like palmistry and fortune-telling." A highly scientific statement. I do not know anything, but I have a right to my own opinion, and I shall stick to it. In Germany, this has been practiced with great thoroughness. It has now reached the United States. They're terrified about the advance of the African bee. They want to get rid of it as quickly as it appears, and so, with the expenditure of millions of dollars, they have set up units equipped with microscopes coordinated with computers and aircraft to be flown instantly to any place. They're spending enormous sums on biometry and the equipment for it in order to combat the African bee. In Germany, on the other hand, people in the institutes conduct classes during the winter for ordinary beekeepers like you and me to learn this art and to apply it to their own bees with little expense, simple apparatus, and it's done all over Germany by people who wish to maintain the standard of their beekeeping. If you read the book that Mrs. Waring so kindly advertised at the beginning, you'll find statistics of how improvement has gone on to such an extent that the honey production of Western Germany is now higher than the honey production of the whole of Germany before the war. And besides the diminution in the size of the country, there is also a diminution of forage because of changed agricultural practices. And in spite of that, the honey production is more than doubled, and that is over the last 30 or 40 years. And an essential, integral part of the process of improving their bees has been the biometry carried out by ordinary beekeepers to maintain the standards of their beekeeping. Now, what is it that we measure? We don't measure just a single bee. Bees vary, just as human beings vary. Even identical twins are alleged to have minute differences, and certainly other close relatives show greater differences among human beings, and the bees have the same variation. We have to remember when we're looking at them how small they are. We can measure our differences in inches, sometimes in feet, but inches for measuring human beings are quite useful. You need a much smaller unit to measure a bee. If you wanted to compare a human being with a bee and measure them in the same way, you'd require a bee as big as a Labrador dog. And it's difficult to imagine. So we have a unit of 1/100th of a millimeter. Fortunately, you and I don't have to get down to that level. It's the researchers and scientific workers who work at that level. But we do, and we need to check these and balance out the variations. We need samples. We take, if we're following the Germans, 25 bees from a colony for a preliminary sample. One reason for taking 25 is that it's easily turned into a percentage, and you can compare percentages of different colonies more easily than you can compare just figures. The French have some mathematical calculation which says that 30 bees will give you a fairly accurate picture of what a colony is like. So you need a sample, if you can get it, of 25 bees or 30 if you want. If you're going in for really serious breeding of a high quality, you want to be quite sure of the progeny, well then you may take a larger sample. And sometimes it doesn't tell you any more than the smaller one. The bees, if you're going to do a full examination, should be young. You take them from near the brood nest, you take live bees, and they want to be killed quickly by being dropped into nearly boiling water or by being killed by ether or some similar method. I've never used ether or chloroform because I never possess any. Dropping them into boiling water seems cruel, but it's instantaneous. Putting them in a freezer might take 2 days. I don't suppose the bees are very sensitive when they're so cold, but it does take a long time, and for certain purposes it makes them difficult to examine. But to start with, I don't like killing bees. If you can collect dead bees from the floorboard of your hive in spring or late winter, you can make a useful examination of them. Wings, as a rule, don't suffer so much, and you can take as many bees as you want, and you can get good measurement of the wings from that. And I would recommend that as a routine thing that you can do in the winter. But when you come to want to know really what a stock is like, you need young bees, because in addition to measuring the wings, you measure the hairs and the width of the tomentha. You like to look at the color and possibly measure the tongues. And for that purpose, you want young bees that aren't worn. And the reason for killing them with hot water and not by freezing is that the tongue remains extended and can be easily excised and measured, whereas if you put them in the freezer, it's curled up and not much use or difficult. That covers the common external characteristics of the bee. There are many more which are used to compare bees from all over the world. Dr. Goetz, as I've remarked, had many more, but he reduced his measurements for the European bees to these few easily measured ones. The others are used so that the variations in the African and other bees can be measured, and we don't have to concern ourselves with them. Our job is fairly simple. The wings are best measured, or most easily measured, by the use of a projector. We take a forewing. It doesn't matter whether you take the right forewing or the left forewing, but when you take a sample, you should take the same forewing from all the members of the sample. All left or all right, but it doesn't matter which you start with. These are best dipped into a solution of alcohol and a little sugar. About a teaspoonful of the alcohol, it dries up fairly quickly, in a dish, and just 2 drops of sugar syrup put into it. That's enough. And even that would cloud the wings, so we adopt Mrs. Waring's modification, and instead of putting them in the syrup entirely, we take them with a pair of forceps and just dip the tip of the wing where it joined the body into the solution. These are then placed one by one on a slide cover, which is open, of course, and if they're neatly arranged, we can get 3 columns of 5 wings. That gives 15 in one slide and 30 in 2, which is a preliminary sample from a hive. They're dipped carefully and put neatly on the slide cover. The syrup dries and causes the wing to adhere to the cover, and then you put the top on, and they're firm and they'll last a long time. You needn't use the syrup, of course. You can have much more fun by holding your breath and putting them down. And just as you put the 15th down, you gasp and say, "That's done it," and they all fly away. And you start again. But if you're devoid of a sense of humor, you can have recourse to the sugar. The knowledge of the sugar was one of the fruits of my expensive trip to learn about beekeeping in Austria, so I'll pass it on to you free of charge. The hairs on the back of the bee are measured, and they are very important. The local bee, the native bee of this country and of Northern Europe, has hairs which are about twice as long, not a little longer, but twice as long as the hairs of the foreign bees, which don't need to keep themselves so warm in winter and for such a long time. And these are measured on the back, on the 5th abdominal tergite. We look at them in profile, and there are different ways of measuring them. A microscope will enable you to measure the exact length, which should be 0.4 of a millimeter. The Italian bee will be less than 0.3, and hybrids will be somewhere in between. The native bee is not less than 0.4. I frequently find it's 0.5 and sometimes even longer. It is a hairy bee. And this can be done in, as I say, 3 ways. One is to put it under a microscope with a measuring graticule. If you haven't a microscope, another means is to have it impaled on a pin to hold it easily, or in forceps, and a hand lens of a magnification of 6 or better 10 with a bit of wire taped to it of 0.4 of a millimeter. And you compare that with the hair, and you find when you're used to doing it, you can see the length of the hair compared with the thickness of the wire, and that gives you quite a good measurement. And once you've measured a few, you begin to be able to see which are long and which are short. And the third way, which is not available to everybody, is to use an Aldis projector, such as we've brought here, remove the slide carrier and insert in its place a strip of cork to which we can impale a bee, a dead bee, of course, so that it's projected in profile on a screen. We need to know the magnification, which can be found by impaling also a pin of known thickness in the cork, focusing that to be till it's a sharp focus, and you know what width it represents, and then it's quite easy to measure the length of the hair. That is the one method I would prefer, but not everybody has an Aldis projector, and I don't know of any way of modifying a modern projector to do it. There are some minor measurements. One is the width of the tomentor. This is measured on the 4th abdominal tergite. The Italian and the Carniolan and the Caucasian bees have a broad tomentum, more than half the width of the tergite. The local bee has a narrow tomentum, distinctly less as a rule than half the width of the tergite, and is rather sparser. Tongues are only measured, it's only necessary to measure them if there's any fear of Caucasian influence. The Caucasian has the longest tongue of any honeybee known, and if it's hybridized with our bees, a lengthening of the tongue is very clearly shown. Certain characteristics can be seen with the naked eye on their lighting board. The 3 other continental races have a narrow, rather pointed body. The local bee is larger and rounder and broader, and the end of the body is blunter than in the pointed shape of the Italian, Caucasian, and Carniolan. Coloration is easily seen and is of much less importance. The Italian bee is distinctly yellow. It has indeed been bred to be yellow. The natural color was variable and had one or two yellow bands. But the breeders soon found that people who imported the Italian bee into England wanted to be distinctive and have yellow bees, so they produced the three-banded Italian and even the golden Italian. But these bees have a yellow band. The other bees have color on them, but it is brown, and it's not of great importance. The British bee is variously described as the old British black bee or the British brown bee. Herod Hempsel denies that there ever was such a thing as the British black bee. I have found, in measuring a large number of samples, that some bees look distinctly brown, but it's because they have brown hairs, a fairly light brown. And when examined closer, the integument, or the horny part of the body, is quite black. Other bees look black to the naked eye, but when observed under a microscope, are very dark brown. And then still others have dark brown spots on the second tergite, or even a brown ring. It's of no great importance. In the same stock it can vary. It may be due to the multiple mating, or some people think it's caused by the weather and varies with the season. It's not of great importance. Far more important is the assessment of the measurements we have taken. They should be plotted carefully and recorded. And there are limits within which they should fall. The wing follows the normal structure of the Hymenoptera bee. There is a long, narrow segment near the fore end of the wing known as the radial cell. Below this, there are three more segments known as the first, second, and third cubital cells. And the third cubital cell is the one to which we pay the most attention. The lower, as displayed on the screen, the lower edge, or as it is actually on the bee, the hinder edge of that third cubital cell is divided by a vein from the cell beyond it into two parts. The one onto the outer edge of the wing is usually the shorter, and the other one naturally the longer. These two are measured, and the shorter is divided into the longer, and this gives the cubital index. It isn't a straightforward measurement. It's two measurements of two parts, and one divided into the other, the cubital index. And this is specific for the race of bee. Carniolans and Italians always have a marked difference between the two segments, and the cubital index is therefore high, more than 2.2 up to 2.8, or even higher than that. The mellifera, or western bee, on the other hand, have these two portions more nearly equal. In fact, in the drone, it's not infrequent to find that they are equal, and the cubital index is 1. In the worker, there is more difference than that, but it's for a pure mellifera worker, it's very rare that it goes above 1.8. And you can see there's a considerable difference between 1.8 in the mellifera worker and 2.2 in the Italian or Carniolan. A hybrid comes between. And then, most unfortunately, the Caucasian bee also comes between and gives the same kind of measurements as would be found in a hybrid. And that is why sometimes, if there is Caucasian influence in the area, we have to measure tongues, because merely from the measurement of the cubital index, we can't distinguish between a hybrid and a pure Caucasian. We take, as I've said, 25 or 30 samples, 30 bees for a sample, and we plot the results of these measurements. We shall find that they form, if we draw a graph, they will form a peak, a single peak that falls away sharply to both sides and comes within the limits of 1.8 on the higher side. And that gives a good picture of what a pure mellifera colony can be. If, however, we find there's the occasional bee strays beyond that limit, we can ignore it. Less than 2% is ignored. This may seem cheating, but very often such a bee is a stray from another colony, and we can find that if we take another sample the following year or later in the season, these strays disappear. If, however, the number of strays increase on a second sample, it will be a sign that the queen has been multiple mated, and among her matings there is a stranger drone which has caused this effect. But merely one appearance of a stray or two strays doesn't matter. If we find that instead of one peak on the graph, we have two, this is a fairly certain indication of hybridization, a multiple mating. And this is a thing which is nearly always with us. I haven't seen it appear and disappear on samples from a given stock, but I have seen curious things happen in our breeding stocks. We had one stock, I've told you about it already, which had appeared to have all the desirable qualities, and all the bees were black, and the samples were all correct. She produced a queen which unfortunately was very badly mated, and nearly all the bees in that stock had yellow marks and many other unpleasant characters. The following year we intended to breed again from our breeder mother, and we found nearly as many yellow bees as black. We couldn't breed any more from her because obviously the multiple mating had now shown, and yet the previous year we'd bred pure bees from her. And wonder of wonders, this cross-mated daughter stopped producing yellow bees and produced nothing but black bees. We didn't risk breeding from her, but it was quite impressive what a difference there was in both stocks in 2 seasons, and the characteristics and the behavior altered with the kind of bee that we were handling. So we didn't take any further samples because we thought from the appearance of the bees it wasn't worthwhile, but in the first case the original breeder queen had shown no bees at all that when we put them through the morphometric tests that gave any suspicion of cross-mating. This is curious because the Germans have recently been saying that when a queen has been mated, the old bees chase her round the hive. And this is done deliberately to make the sperm migrate from wherever it was put to wherever it should be. I've forgotten the words, but it's part of the mating process to make the queen effective. The bees chase her around, and they allege that the sperm from the different drones gets mixed. Well, in our bees, it was quite clear that although there was a certain amount of mixing, we got some black with the yellow in the daughter queen, and the following year we got a great deal of yellow among the black of the mother queen. In each queen in 1 year we had nothing but black bees. So clearly the mixing of the sperm isn't altogether complete. That was a thing we could see with our naked eyes and did not need to be confirmed by biometric tests. We take another measurement in the wing called the discoidal shift. Will you please pay attention to the language? Many members of BIBBA call it the discoidal index. It is not an index. We measure just a simple straight measurement of the hairs on the back of the bee. We make a simple straight measurement of the width of the tomentum. If we wish, we can make a tomentum index by dividing the width of the tomentum into the width of the whole tergite. And similarly, when we make the cubital index, we divide one measurement into another. When we come to the discoidal measurement, it is not an index, and my brother's translation of discoidale Verschiebung, which was the original German term, was discoidal shift. Other people seem to think that's rather vulgar, and they call it the discoidal transposition. 3 or 4 syllables instead of 1, and I'd rather be vulgar in a short word. The discoidal shift. This is a bit more complicated to describe, but you'll see it quite simply on the measurement. We have a special kind of chart for measuring it. Once again, the wings, the same sample of wings, is projected onto the wall, and we hold up this chart. It consists of a line which is placed against the radial cell so that the line passes through the 2 ends of the cell. Projected downwards from this line at right angles is another line, and we move that to coincide with the joint on the lower edge of the radial cell. We then trace its course further down, and we see a point on the discoidal cell which lies below the cubital cells, a point towards the tip of the wing, and we observe the position of the line in respect of that point. And according to where it is, it's classed either as positive or negative or 0. 0 obviously lies between positive and negative. Well, I can't think of anything more to say without any work and diagrams. So I propose that if everybody agrees, we have an afternoon session. Well, we're going to show the measurements, and I hope it'll make it a little clearer than it was before when I had no illustrations. We shall start with the wings. I'd better give a brief description of them from the outline. This is the best way that we know of measuring the wings. You can get a great illumination without straining your eyes, as large an enlargement as you get with a microscope, 40 enlargement, and people can see it. 2 or 3 people can work, one operating the projector, one taking the readings, somebody else noting them down. And so this is a convenient way. for preference, we project it on a wall, not on a screen, because you want something firm. This actually is a blackboard and not quite firm, but it doesn't matter. The fact that it's black and you can't see the outline doesn't matter in the least, because when it's measured against white paper, you'll see perfectly well. Or I shall see it when I'm measuring. So that is what we do, and we'll have it projected. Yes. Now, I'd better explain what I couldn't make quite clear this morning. You see on the blank sheet the outline of a typical wing. And it's quite easy to learn the names. The long cell on the forewing is called the radial. The three below it are number 1, number 2, and number 3 cubital. The big square one below is the discoidal, and that is all we need to concern ourselves with. And what we measure for the cubital index is the small segment, which is always labelled segment B, and the long segment, segment A. Measure the two and divide the short into the long, and that gives you the cubital index of the wing. Now, there is a drawback leaving it just at that point, because as the cubital index changes, it isn't just a change in one part, the two change. And so there is, if they are divided, as the Germans do, into classes, there's, the higher classes cover a much wider range than the lower. So the classes have been rearranged on a mathematical scale. I think it's a logarithmic scale. We don't need to worry because it's been done for us. And with the fan, invented of course by a parson, a beekeeping parson, Farrer Herold, we can measure quite simply. We don't have to bother about the actual length of either A or B. We measure the position on the fan, and that gives us the class. And so we just enter up the class, and we don't have to do a division. I said this morning you can take either all left wings or all right wings, and the fan is produced in a double form for that purpose, and we shall only use the fan for the right wing. And it has a kind of ladder. The middle line of the broad parts goes on the joint where the two segments meet. The shorter segment fits on the right-hand side of the ladder and the longer segment on the left. Now, the short segment does not have to be on one of the rungs of the ladder, but it must be parallel with the rungs, even if it lies between, or when it lies between. But we put the middle line of the ladder on the middle joint and adjust it until the other leg of the ladder goes through the point. This segment doesn't lie exactly on the line, but it doesn't matter. We look for where the joint is, and it comes on the third line out, and that is marked at the bottom as 1.4. That is, no, 1.6. We enter that on our chart, on our record, and then we shall take another one, and this looks very similar. You have to be careful to get the leg of the ladder through the middle of the joint, which isn't easy because it's rather spread out. Now this is somewhat lower, and it will be 1.5 And you do that for all of them. Now there is the other measurement that I told you of this morning, the discoidal shift, the discoid Shibo, and that requires a different chart. This has undergone some evolution. I believe Dr. Goetze, who invented it, just had negative and positive. John Lewis decided that 0 could be a zone instead of a point, and so we calculate the 0 on either side of the middle point of naught. Now, the way this is measured is to take this straight line and put it through the radial cell, and this goes through the middle joint of the radial cell, and then we read off at the bottom according to the discoidal point. That is, the long line goes through the radial cell, the vertical line comes through this joint, and we look for the relationship between this joint and the vertical line. I think it's not out of place to give you a warning. Dr. Goetze produced a diagram which many people have copied, in which the vertical line comes through this point. That's quite irrelevant whether it does or not, but many people have seen it and tried to get a line through both and made nonsense of the measurement. It might go through that point and it might not, and it doesn't matter one way or the other. Now, I get that through the ends of the radial cell, through the middle of that joint. I follow it down to where this joint is. That is 0, and this is 3. This is -6, -6, and that is how it's entered up. The two are entered up together in the chart, and when all the 30, 15 in each group, have been done, then you work out the result in a scattergraph. It will serve for one sample of bees. It is divided roughly into 4 segments, the negative and the positive, with a 0 zone in the middle, slightly darker lines bordering it, 3 places for it. And up this side we have the cubital index, discoidal shift and cubital index, and it's plotted on that. And on the opposite side in the booklet which you have, there is a real example of various colonies that were done. The group B8 was one of our breeder colonies. There are a few, there are no samples of the discoidal shift in the 0 rating, and of course therefore none in the positive at all concentrated in the negative rating. And the cubital index there are 2 which come to 1.9, all the rest are well within the limits, and it's grouped in a ring. It shows a homogeneous colony, and that was one of our breeder colonies. Now, up in this corner, we have a sample which is high cubital index, positive discoidal shift, and that shows strong Italian influence, but the samples are scattered. Some go into negative, some actually go into positive, and some go down to a low cubital index. That shows a very mixed colony of bees, a very mixed population, and predominantly Italian. And from these scattergraphs, you can read off the quality of the bees. The Germans don't do it that way at all. They don't use the discoidal shift now very much, so far as I know. And Dr. Rutner tells me he never uses it at all. And so they draw ordinary graphs, which you'll be familiar with, and you get a shape like that. You'll find that those of you who have bought the books can find examples, and you'll see illustrations of a pure line that has just a single cone, and one with mixture that has a secondary peak, and so on. And some with a flat peak instead of a sharp one, showing mixed blood. And you can learn quite a lot from the groupings of those on either the graph or the scatter graph. And that's the information we get from the wings. You can get it from all the bees, and you can get very accurate information from them. And that is the most important of the measurements we make. Now, this is not so important, but it's useful to do it. If you want to know how to excise a tongue, the world champion tongue exciser is Paul Hans. He came to me, and I apologized that I hadn't been able to set up my microscope and there were difficulties, and he looked at the tongue and said, "I think I can do it with my naked eye." And so I gave him the tools, and he looked at it, and he made a beautiful excision of the tongue, thereby making history. And when we had a workshop at Moulton, at which he was present, I invited people to compete with him, and one lady who may be as old as I don't know, she's not one of the youngest, she sat by it and said, "If he can do it, I can," and so she did. And so he is better able to tell you about the excision of tongues than I am. Now, what we measure is the whole tongue. If you consult a book like Dade, you'll find diagrams, you'll find the different parts are named. For this purposes, you don't need to bother about the names, so long as you get the whole tongue out. That's the extreme tip, and this is the other extreme tip. And these pieces, if you can remove them for measuring, well, it looks better. But I found many times when I've managed to excise a tongue and tried to pull off these other appendages, maxillary palps and other things, I simply broke the tongue up, so I gave up. And I'm quite content with a mounting like this. There's also the little spoon with which the bee can lick up the honey, and the mentum, which is the very end of the tongue. And you can see this isn't quite so good, that's curved and not so easy to measure. That's also curved. That's a very good one. And this has come out very well with the hairs. They don't concern us, it's only the measurement. That is fairly complete with all the other things as well that aren't required for the measurement. It's just the tip up to the mentum, which is rather clouded in this one. Now, you only need to make measurements of the tongue if you are afraid that there's Caucasian influence in your neighborhood. Because, as I explained, you can't distinguish by the cubital index alone between a pure Caucasian and a first hybrid between Italian and British. So the tongue then becomes essential. But otherwise, I'm glad to say, we don't often have to use it. There's another thing I might mention, which I do, and not everybody does. The usual way we've done has been to take a sample of 25 or 30 bees, pull the wing off, mount it, and throw the bee away, as a rule, and just measure the wings. But when you're measuring other parts as well, it's interesting to compare them. So I have a little box. Any kind of box would do. Here's a box which has once held tobacco. That would do quite as well. I've divided it up by pieces of postcard. It's which happen to be conveniently handy, and it forms 3 15s. It's 3 5s of 15. It holds just as many bees as are required to fill one slide. And I number them all, 1, 2, 3, and then the second box will be 16, 17, and so on. And I know where each bee is. When I can either have a pile of bees, or I can fill this up first and take them out one by one, or if I have a pile of bees, I take a bee, take off its wing, put the bee in number 1, and mount the wing, and so on. Now, we don't usually require 25 samples for the smaller, the minor, less important measurements. 10 will usually do for that. So we can either take 10 at random or take the first 10. But we note down the result, the colour, whether it's black or brown integument, whether it has a ring or whether it has only spots of brown. Note that down under the number where the bee has been taken from. Under the same number, note the hairs and the thorax. And then if you find a bee, say you've picked out a yellow bee, if this has the proper wing shape and the possibly proper hairs, it will very likely have long hairs, you'll know this is a hybrid. If, however, you find a bee with yellow markings, and it has short hairs and a broad thorax and a high cubic index, you can say this does not belong to this colony. Throw it out and get another bee, because if it's got all those markings, it's a stray from another hive. I've had arguments with people about this. They say I'm cheating. Well, no. If, as I say, yellow markings are combined with non-Italian characters, I would readily admit this is the product of a hybrid mating in this colony. But if all of the features that I've measured are Italian, it doesn't compare either with the mother or the drone, it's a stray. And using this method of separate numbering each bee and comparing the results for each bee is a good way of deciding whether it's a stray or a hybrid. And I think it's well worth the trouble of doing it. Anything more? I think that's enough on theory. Are there any questions before we get down to the really serious business of mounting wings and measuring these things for ourselves? No questions? Well, we'd better get to work.